We will not talk about the foundations of CHOReOS, we'll talk about its theory and moving from theory to practice. And CHOReOS is about large-scale choreographies for the future internet. I'm Pierre Chatel, and I work for Thales Advanced Studies in the Smart System Lab. What is CHOReOS? One big question. It's a choreography-centric SOA for services and things. And why do we know that? Because we need to sustain decentralized service choreographies in order to support the future internet and large-scale properties. And specifically in CHOReOS, we have a focus on Internet of Service, or IOS, and Internet of Things. And how do we do that? We do that by introducing a specific development process and an IDRE, integrated development and runtime environment. And this is for the coordination of services through these choreographies. And you can see here in the diagram that CHOReOS is at the center of the concerns between future internet and large scale. Let's say large scale, not ultra large scale, for now. So this is a brief outline of the presentation. I will quickly do a small reminder on what is the differences, the main differences between orchestration and choreographies, then going to a use case, and some extract of the contributions that were made in CHOReOS from the last 2 years. We won't have the time to do an overview of all the contributions, just the main ones. So, orchestrations versus choreographies in the real world. So orchestrations are like a local or decentralized perspective. You could say that, as you have here on the left, that each player in our orchestra needs to strictly follow instructions that are coming from a conductor. And in the SOA world, this conductor will be the orchestrator. The orchestrator that reads at runtime, for instance, a BPL file. So it refers to a specific business process with a specific goal or business goal. On the other hand, that you have on the right here, a choreography is a global or distributed perspective. And you could say that dancers dance following a global scenario and without a single point of control, without this orchestrator. So in SOA, this describes a protocol for direct peer-to-peer interaction, direct, without the orchestrator. And this is the main difficulty that we have in CHOReOS, how to do that without the orchestrator. Choreographies help us deal with what we call future internet ETs, like scalability, heterogeneity in the diversity of services, user types, mobility, and also awareness and adaptability. So all these ETs. And in CHOReOS, we have projection of choreographies in 3 different use cases. I will focus on one in the airport. It's called passenger-friendly airport, and the context is air transportation, service to passengers. We want to do improvements of services to this passenger, to improve also the fluidity inside the airport, and we do a proof of concept on that. And CHOReOS enables us to do dynamic rebinding and replacement of services, so based on loose coupling, and also distributed coordination. We have Thales in ORIA and Linagora that contributes to this use case. For instance, Linagora provides the easy USB bus for communication. And we follow a passenger from home to its landing. And this is a BPMN diagram that show the subparts on the landing of the passengers inside the airports. So it's passengers arrival, handling, and tracking inside the airport. I will quickly zoom here. So I think that you are not able to see much here, but this is a BPMN2 choreography that we do using Magic Draw that is used in the CHOReOS project. Each task here is a direct communication between multiple peers, for instance here between the airport and the passengers. And the main thing in this choreography is that on the left side, the passengers have not landed, and on the right side, we are able to dynamically incorporate the service that are provided by the passengers' smartphones, like a service for measuring the ambient noise level or the location of passengers. So the service provided by the smartphones are directly incorporated in the global choreography, like the services that are already inside the airport, like the display, the public displays, or the microphones, etc. So this is the main focus here. So let's look at some of the things that allows us to do that. The IDRE, a specific CHOReOS development process, and what we call choreography synthesis. The IDRE is the thing that is at the center that integrates all CHOReOS components into one single platform. You have formally grounded abstractions and models, you have a dynamic choreography-centric development process, a middleware, and governance, verification, and validation. So the IDRE is the packaging that at the end of the project will allow you here to check out CHOReOS and to retrieve a single package. The specific development process, which is part here of the IDRE, and the middleware we will see now. So first of all, the development process. It's a technologically independent characterization of the strategy that we use during the choreography lifecycle. It's nothing very new because it's usual software definition activities like goal and requirement specification, verification and validation, model-to-model transformation, but they are structured in a CHOReOS specific way. And we do that, we specify this using the same language that we use for choreography, in fact, so it's a little bit fractal. We use BPMN2 here. And this is the abstract view, and this is the detailed view. With a lot of tasks, you have the productions, the type of documents that CHOReOS consume, and the type of documents that are produced, and all the tasks. So I invite you to check out this CHOReOS process in more details on the website. I will just focus today on this part, which is the choreography synthesis. So how does it work? It is the main focus, the main core of CHOReOS that allows us to run choreographies. So we move from a BPMN2 choreography specification, like the one you saw before, and to synthesis of artifacts that allows runtime of this choreography. And of course also discovery of the available services. So the first step is moving from BPMN2 specification and apply model-to-model transformations. And we obtain what is called a choreography labeled state transition system, or CLTS. This is in fact the global coordination logic that is specified in the choreography at the global level. Then we need to project this global single choreography logic into multiple expected participants. So we obtain, by transformation, sub-CLTSs. And this is the expected participant behavior. This is not the actual services. This is the behavior that we want to obtain from services. And finally, of course, we need to discover the available services and produce what is called coordination delegates, or CDs. These coordination delegates are the code, Java code in fact, that is produced based on the automatons that are produced here. The CLTSs are in fact state machines. So state machines and then code generation to obtain CDs. And these CDs will manage the available services at runtime based on the global coordination logic that is not lost in the process. This is the kind of CLTS you have. This is a global CLTS. It represents the choreography that you saw in BPMN2 before, and this is the state machine with the states and the transition between the states. And a transition here is enabled if you receive a specific message. So you move from state to state, and only from allowed state to another allowed state. Then you project this, so you obtain a specific CLTS for each participant. We are in the airport use case. We will have a CLTS for the airport, for the ATC, and for the amenity providers. So, third step, obtaining the coordination delegates. And I represented them here as little policemen, because in fact these CDs, what they do is they replace the orchestrator, the single orchestrator that will be used, in an orchestration-based logic. But then we move to this choreography-based logic, and we dispatch the coordination logic between all the CDs. These are the green boxes that you have between each participant. And for each communication, a specific CD, coordination delegate, will allow a specific message only if it is allowed at a specific point in time. So they control all the execution and the exchange of messages between services. So, concluding, CHOReOS enables us to have choreography-centric SOA. We sustain decentralized service choreographies. Decentralized because you have no single point of failure of control. You remove the orchestrator. We support Future Internet and large scale. We focus on Internet of Services and things. I didn't talk about things today, but they are used a lot in the CHOReOS for sensors, for actuators. And as I said just before, these coordination delegates that are the center, the core of CHOReOS, are like policemen, and they ensure the correct execution or enactment of the choreography following its coordination logic that is formally defined in this CLTS language. So 1/3 of the project is still to be completed, and the end of the project is on schedule for the end of 2013. I hope that next time I will be able to show you nice GUIs and interfaces of the tooling that is in the IDRE. And of course, since we are at OW2 here, all CHOReOS specific development will be released as open source software on a BSD-like license. So this is the website, and you can go check out to have more details on CHOReOS, and also retrieve my old presentations at choreos.eu. Thank you.